And it's all our group member, and we are glad to do the presentation for you. And my name is Zhe Huini, and
my name is Yin Qing. This is Hao Wang.
My name is Li Bohe.
Thank you.
Here I will show you how the project works. If you want to simulate the stock price, just click Simulate here and input all the numbers in. I will put 20 as stock price, 1 as time increment, 0.2 as the expected return, and 0.4 as volatility. And I will set 200 as the time period. Then all the data will be shown here. And if you click Create Chart here, the chart will display here.
Today we are glad to do the presentation of how to simulate stock price by using GBM model in front of the camera. And I will do the introduction of GBM and the first part of the code. Introduction: a geometric Brownian motion, its GBM, is a continuous time stochastic process in which the logarithm of the randomly varying quantity follows the Brownian motion with drift. And it's an important example of stochastic processing satisfying a stochastic differential equation. It's called SDE. And in particular, it is used in mathematical finance to model stock price. In the black squirrel model, what is known to all is that the stock price is hard to predict, but GBM model can provide us with a general framework. The GBM model has 5 assumptions. 1, they are continuous in time and value. 2, current stock price relevant for predicting future price. And the third one is proportion return of short period of time in normally distributed. The fourth one is price of stock are log-normally distributed, and the last one is continuously compounded return for stock is normally distributed, and there are also have 5 variants stock price now. And the GBM model has 5 assumptions. And the first one is they are continuous in time and value. The second one is current stock price irrelevant for predicting future price. The third one is proportion return over a short period of time is normally distributed. And the fourth one, the price of stock are log-normally distributed. And the last one is the continuously compounded return for stock is normally distributed. And it also have 5 variant stock price now is the first one, and the time increment is the second one, and the last 3 one is expected return, volatilities, and the number of simulations. And it's the first part of the code, the preparation of the simulation button. And the next page, the first part, the function is to allocate storage space for definition of X variable. And the second one is to clear the last output data so as not to affect the next data output. And the next page, this part function of it is to enter a new variables and make them normative. And the last part, the function is to it's the location of the variable output.
Before writing out the code, we have to figure out the 3 important equations of geometric Brownian motion model. We can figure out the relationship between the equations and the assumption based on the slide. Also, we can see the 2 components of simulated stock price and the relationship between the 2 components and the stock price. So after we have done all the preparing works, we can start to simulate the stock price. So this is the complete simulation code. The beginning part of the code is help us to better understand the output data. The most important part is the looped code. There are 3 loops because I want to get 3 groups of simulated stock price and components and find the average of each type of data. The loop codes are very similar. So I just compile one of the loop codes. So see here, n is the simulation days that we have imported, and the loop is to output the simulated results day by day. At first, we can get the random number that is normally distributed with the help of Excel function. Then we can follow the equation here to calculate the simulated stock price of next day. The next code is to compute the certain component of simulated stock price, and the uncertain component equals total stock price minus certain component. These four lines of codes are used to output the simulation results at the specific output location. Finally, we have to save old price before calculating next price of next simulation day. The loop is over, and the computer will help you to calculate the rest of simulation results automatically.
In this part, I will introduce how to display our results in a chart to make the results more intuitive. First, we set a range to confirm the location of the chart. Then we named all the data in our form as total, certain, uncertain, data, average total, average certain, and average uncertain. Then we can use those data in our chart. And then we set the top, left, right, and the height value to make sure the chart is full of the whole area. Next, we will use the data in the chart. We determine the location of each point in the chart by the first two lines of code, and all the connection of points makes lines, and the lines form a chart. In the third line of code, we named the line. And the next code is all the same operation. Then we named the x-axis and the y-axis to make the value make sense as price and days. And then finally, we named the whole chart as simulating stock price.
After our group making the VBA, we did a lot of experiments to get the conclusion about the future stock price. We aimed to the 5 different variables. We changed one variable in turn to get the reasonable result. Look at the first picture. This picture is for the variable of stock price. We look at the stock price. We can find the initial stock price don't affect the future stock price. Next, this picture is the variable of time increment. In this picture, we manually look at the stock price. We can find with the time increment increase, the future stock price will fluctuate. Next, we talk about the variable of the expected return. In this picture, we manually observe the certain price. We can get the result of the picture is that the expected return is determined at a certain price and lead to the stock price change indirectly. Next, as for the volatility, we observe the average stock price and the stock price. We can find the result easily. The high volatility makes the stock price more dangerous. Finally, this picture is for the variable of the measured days. In this picture, we manually look at the stock price. We can find the more days will lead the future stock price fluctuate more frequently. After our experiment, we can get some summaries. First, the initial stock price does not affect the future stock price. Second, the time increment will make the future stock price fluctuation. So after our group making the experiment, we can get some summaries. First, the initial stock price does not affect the future stock price. Second, the time increment will make the future stock price fluctuation. Third, the expected return affects the certain price directly and affects the future stock price indirectly. Next, the higher the volatility, the more risky the stock price. Finally, the more measured days, the future stock price will fluctuate more frequently.